So this is our presentation on how to draw a free body diagram, or we can call them force diagrams. I am going to go through many of these slides. We started out talking about what were the different forces, so you should be aware of those, the contact and non-contact. And then I run through a couple examples of drawing force diagrams, like on the flamingo, on the sled, and on this skateboarder. So now I'm going to do a couple of these on some different other situations. So if I was to look at this for a free body diagram or a force diagram for the bike and person, so I'm going to treat them as one unit, it would look like this. So I'm going to represent, this is my object I'm looking at, and then I need to make sure I look at what is touching this. So I'm treating this as one object. So that'd be my dot. Okay? So I'm going to draw that over here. Now, whenever I have something that is on a slope, I usually do a dashed line, like I said in the earlier slides, and I'm going to put my dot here. We know force gravity acts straight down on that bike and the boy. Okay, so we're treating them as one unit. Okay, so that would be our first force that we should recognize, and it is straight down. Now, the other one is this surface right here is pushing up on the two of them. So that would be a force normal. That force normal is always drawn perpendicular to the surface. So this should be at a right angle. So this is my force normal. Now, on this one, we are going to neglect air resistance. So we aren't going to count that as part of this. And this person is moving at a constant velocity. We know that. Now, in order for these wheels to go up the ramp, there is something, they have to have grip. We call that force traction. And then the other force that's acting on them would be the force friction. So I'm going to label those forces on there, and it would be opposing the motion that this person is moving. Okay. Now, in this situation, I want to also break down this force into components. So this force gravity here, this would be the same as there is a force that's pushing the biker into the ramp, and I would call that force gravity in the y direction, because that's the y direction. And then this would be the force gravity in the x direction that is pulling the person down the hill. Okay, so I can show congruency here between two forces. The two forces that would be congruent would be this and this. Those two are canceling each other out. This guy is not changing his motion, or the bike, in the vertical direction. So those two are congruent. I could say, when we do look at congruency, I could say this force plus this force must equal this force, because since he's at a constant velocity, the forces are balanced on this object. Now, usually we only show congruency marks usually when it's one force cancels another force. That's why I didn't use congruency marks there, but I did show you that these two, this one plus this one, would equal this one. Okay, we're going to look at example number 6. Example number 6 here is a man doing a maneuver called an iron cross. So this is what we're looking at. Is this man as he's doing this maneuver. So we're going to just draw the force diagram right here on him. So we know we have two contacts right here and right here. And we're going to use the rope as our forces. So we have force gravity, which is pulling downward. And then we have these two ropes. So these two ropes are pulling upward. So we would have force tension 1, and then we'd have force tension 2. These two forces of this tension since this guy is at rest, is really congruent to this. We could show that since they're both pulling upward, they would each be supplying a force, and that force together would equal the force gravity. So example number 7 is we have the skydiver who is slowing down after the chute opens. So we are going to look at just the skydiver here. So we have to look at what is touching him. It looks like it's the ropes. So we know there's force gravity acting on the skydiver, which is pulling him downward. And then all of these ropes we're going to treat together as just one unit. We're going to say force tension. There's a lot of tension there being pulled. Since he is slowing down, these would not be congruent. Now, the forced air resistance is mainly acting on the parachute, and we're not looking at the parachute. We are looking at just the skydiver. So that force tension would be greater than force gravity, and it's causing him to slow down. So there is not congruency. So this would be an example of a rocket being launched. It's by SpaceX. So if we looked at this rocket has force gravity acting on it as it's being launched, and you see the explosion of the gases and stuff. That explosion is what we call force thrust, of those gases pushing on there, which causes the rocket to propel forward. As it's moving, there would also be some force air resistance or drag on that rocket too. Now, these would not be congruent because this is accelerating, so they would be unbalanced forces on this because it's accelerating into outer space. So this would just be a couple examples of doing force diagrams.